Inside the freezing, cramped cabin of the Eagle lunar module, Buzz Aldrin stared down at the floor. Resting in the abrasive gray lunar dust was a snapped piece of plastic. It was the engine arm circuit breaker, the single switch required to ignite the ascent engine and send them home. Without it, they were permanently stranded. Simultaneously, nearly 250,000 miles away on Earth, a horrifying document sat on President Nixon's desk. Titled "In Event of Moon Disaster," the prepared speech detailed exact protocols for abandoning the two men, severing all radio contact, and leaving them to run out of oxygen. What they saw next would change everything we thought we knew. To comprehend the absolute terror of that snapped plastic switch, we must first rewind the timeline to the descent. The very act of landing on the lunar surface was a horrifying plunge into the unknown. As the Eagle module plummeted toward the gray wasteland below, the Apollo guidance computer, the digital brain responsible for keeping the astronauts alive, began to fail. Warning sirens blared inside the tiny, freezing metal box. The display flashed a 1202 program alarm, followed rapidly by a 1201. For the engineers at Mission Control in Houston, these warnings were a nightmare. The rendezvous radar hardware was feeding a massive overload of unnecessary data into the computer system, overwhelming its limited processing capacity. The computer was effectively choking to death while attempting to navigate a controlled fall onto another celestial body. They were seconds away from a mandatory mission abort, which would have fired the ascent engine prematurely and hurled them back into orbit, assuming the overloaded computer could even execute the command. The mission was saved not by hardware, but by the sheer brilliance of software engineer Margaret Hamilton. Anticipating the possibility of a data overload, Hamilton and her team had designed the computer's architecture to be asynchronous. The code was specifically written to recognize when it was overwhelmed, ruthlessly terminate low-priority tasks, and dedicate every ounce of its processing power solely to the critical functions required for landing. The digital brain cleared its own throat just in time, allowing the descent to continue. However, the computer's brief struggle had thrown them dangerously off course. As Neil Armstrong looked out his triangular window, the automated guidance system was flying the Eagle directly into West Crater. This was not a flat, safe landing zone. It was a massive depression the size of a football field, completely surrounded by automobile-sized boulders. Landing there meant the fragile spacecraft would shatter on impact or tip over, trapping them forever. With the lunar surface rushing up to meet them, Armstrong took manual control. He fired the thrusters, pitching the spacecraft forward to fly over the deadly crater, desperately searching for a smooth patch of dust. But this evasive maneuver consumed a massive amount of highly volatile fuel. Back on Earth, the telemetry data was terrifying. The flight controllers watched the fuel levels plummet toward the absolute limit. The radio crackled with the voice of the capsule communicator calling out the remaining time. 60 seconds, then 30 seconds. That was the barrier between survival and oblivion. If Armstrong could not place the landing pads firmly on the lunar dust within 30 seconds, the engine would ingest helium pressurant instead of fuel, flaming out instantly. Or they would be forced to punch the abort button, triggering an explosive separation right above the treacherous rocks. The astronauts were hovering in a vacuum, balancing a fragile machine on a pillar of fire, watching the digital fuel gauge count down to zero. They touched down with perhaps 15 to 20 seconds of usable thrust remaining in the descent stage tanks. The men had barely survived the most dangerous descent in aerospace history. But what no one expected was, the tranquility of the lunar surface is a beautiful lie. From our distant world, the moon appears as a pale, silent sphere of peace. But the physical reality of this alien environment is profoundly hostile. When Armstrong and Aldrin finally completed their historic moonwalk and climbed back into the Eagle lunar module, they brought a piece of that hostility inside with them. They were covered in lunar regolith, a substance far more dangerous than ordinary dirt. On our home planet, geological forces like wind and flowing water constantly weather down rocks, tumbling them over thousands of years until they become smooth, harmless grains of sand. The Moon possesses no atmosphere, no wind, and no water. For billions of years, the surface has been bombarded by micrometeorites, shattering the bedrock into a fine, powdery dust. Because there is absolutely no weathering process to dull the edges, every single particle of lunar regolith is razor-sharp. They are, in essence, microscopic shards of glass. When the two men sealed the hatch and repressurized their cramped, freezing cabin, they began the arduous process of removing their bulky extravehicular activity suits. As they did, the dark, abrasive dust that coated their boots and gloves began to float into the air they were breathing. The moment this pristine, irradiated dust came into contact with the oxygen-rich atmosphere of the spacecraft, a sudden chemical reaction occurred. Both astronauts immediately reported a pungent, overwhelming odor filling the small cabin. Armstrong and Aldrin described the smell vividly. It was the distinct, acrid stench of wet ashes or the sharp, metallic tang of spent gunpowder. This scent was not merely an interesting scientific observation. It was the smell of a lethal, invasive threat. The regolith was highly abrasive and carried a strong static electric charge, meaning it clung stubbornly to every surface. It coated the instrument panels, worked its way into the zippers of their pressure suits, and severely scratched the visors of their helmets. But the most unsettling danger lay hidden in the mechanical integrity of the spacecraft itself. These microscopic shards of glass posed a severe threat to the vital rubber seals of the hatch. If the abrasive dust degraded those seals, the pressurized air keeping the astronauts alive would relentlessly leak out into the deadly vacuum of space. The very ground of the celestial body they had just conquered was actively attempting to destroy their fragile sanctuary. Let's go back to the risks mentioned at the beginning of the video. To fully grasp the sheer terror of that severed plastic circuit breaker, we must first examine the mechanical heart of their only vehicle home. The Lunar Module Ascent Engine was built under an extreme aerospace engineering philosophy. It was meticulously designed to produce exactly 3,500 pounds of explosive thrust. Instead of utilizing complex, fragile ignition systems, the propulsion engineers opted to fuel the chamber with a highly volatile hypergolic mixture, consisting of Aerozine, 50, and nitrogen tetroxide. These specific chemical compounds possess a terrifying and highly effective physical property. The very instant they make physical contact with one another, they violently combust. This brilliant design entirely eliminated the need for mechanical spark plugs or complex turbopumps, purposefully minimizing moving parts that could potentially fail in the unforgiving vacuum of space. However, this relentless pursuit of mechanical simplicity came with a brutal, uncompromising caveat. The space agency had made a calculated, extreme decision. The Ascent engine possessed absolute zero backup systems. There was no secondary combustion chamber, no redundant engine nozzle, and absolutely no rescue ship sitting on a launch pad back on Earth ready to retrieve them. The mathematical equation was chillingly straightforward. If this single, solitary engine failed to ignite, the two astronauts would permanently die on the lunar surface. That is exactly why the broken piece of plastic resting in the abrasive dust was an absolute nightmare. While wrestling out of his bulky portable life support system backpack within the impossibly tight confines of the cabin, Aldrin had inadvertently struck the engine arm circuit breaker. The physical impact sheared the vital toggle completely off the control panel. Without that specific switch, the electrical circuit required to open the fuel valves and trigger the hypergolic reaction was completely dead. All hope effectively collapsed. As the lunar night approached, outside, internal power was severely rationed to conserve battery life, and the temperature inside the thin metal compartment plummeted to a freezing 61 degrees Fahrenheit. The two men were left shivering in a dark, toxic environment, acutely aware that a broken switch stood between them and survival. While they froze, human civilization had already prepared for their imminent demise. Buried within historically declassified archives lies a chilling memorandum drafted by speechwriter William Safire and sent to the Chief of Staff, H.R. Haldeman. The document was titled, "In Event of Moon Disaster." It outlined the exact cold protocols the government would systematically execute if the ascent engine failed to fire. There was no contingency plan for a rescue. The president would first telephone the astronauts' wives to deliver the fatal news. Following this grim duty, a clergyman would perform a public prayer commending their souls to the deepest of the unknown, deliberately mirroring the solemn, final protocols of a traditional burial at sea. Once the prayer concluded, the space agency would execute the final, devastating step. They would permanently cut off all radio communications with the lunar module. The two most isolated human beings in the cosmos would simply be abandoned, adrift in absolute undisturbed silence, waiting for their finite oxygen supply to slowly and inevitably run out. While two astronauts faced the freezing terror of a broken circuit breaker on the desolate lunar surface, a distinctly different kind of psychological endurance test was unfolding, exactly 60 miles above their heads. Aboard the command module Columbia, Michael Collins was orbiting the moon entirely alone. He was tasked with monitoring the complex spacecraft that served as their single ticket back to Earth. However, his specific orbital trajectory carried a profound and terrifying consequence. During every single orbital cycle, the Columbia module flew directly behind the far side of the moon. For 45 minutes at a time, the massive, solid bulk of the celestial body completely blocked all incoming and outgoing radio waves. During these recurring 45-minute periods of absolute blackout, Collins lost all communication with the flight controllers at Mission Control, and he completely lost contact with the Eagle module resting in the dust below. In those stretches of absolute radio silence, the sheer physical scale of his extreme solitude was entirely unprecedented in human history. As he drifted through the pitch-black orbital shadow, there was absolutely no living creature near him, within a radius of hundreds of thousands of miles. His closest fellow human beings were either stranded on the lunar surface or safely secured on Earth, nearly 250,000 miles away. He was a solitary biological organism enclosed in a fragile mechanical shell, floating through an endless, uncaring void. This physical isolation was matched only by the crushing psychological burden he was forced to carry. Worn continuously around his neck was a detailed technical notebook containing 18 distinct contingency plans. These 18 emergency procedures dictated exactly what orbital maneuvers he needed to execute if the Eagle encountered a catastrophic failure during its crucial ascent. He studied the mathematics of rescue missions, preparing to alter his own orbit if his crewmates survived a partial launch but failed to reach the correct altitude. Yet, the most chilling reality was the singular scenario he could never resolve. In his subsequent memoirs, Collins candidly reflected on the grim protocol surrounding a total ascent engine failure. The harsh truth is that if the Eagle had not been able to take off from the lunar surface, he would have had to ignite his main engine and fly back to Earth entirely alone, leaving his two crewmates behind to perish in the vacuum. Knowing the immense psychological guilt and the heavy historical scrutiny that would follow such a tragedy, he recorded that returning without them would have rendered him a marked man for life. This is where the story takes a cosmic turn. With the engine arm circuit breaker violently snapped off, the two astronauts needed a physical object to bridge the gap within the control panel and successfully close the vital electrical circuit. A seemingly obvious solution would be to use a standard tool, perhaps a metallic screwdriver or a similar implement, to dig into the instrument panel and forcefully bridge the connection. However, introducing a highly conductive metal object into the exposed live circuitry of a fully powered spacecraft was a terrifying and completely unacceptable gamble. A single misplaced spark or a sudden static electrical discharge could instantly short-circuit the entire primary electrical bus. The electrical bus functioned as the central nervous system of the lunar module. If that system failed, the spacecraft would die completely, instantly killing the life support controls the guidance computers, and any remaining chance of survival. Instead of risking catastrophic electrical failure, Buzz Aldrin relied on pure, calculated ingenuity. He reached into the shoulder pocket of his pressurized spacesuit and retrieved a simple, commercially available item, a plastic Duro felt tip marker. It remains a persistent cultural myth that the heavily engineered pressurized Fisher space pen was the tool that saved the Apollo 11 crew that day. That popular story is historically inaccurate. Aldrin deliberately chose the Duro marker precisely because its outer casing was constructed entirely of non-conductive plastic. He carefully guided the blunt end of the marker into the narrow opening, where the toggle had broken away, pressing firmly against the internal metallic contacts. The circuit breaker successfully clicked into its closed position. The electrical current flowed. The ascent engine was officially armed and ready, yet repairing the broken switch was only the first step in a sequence of profoundly brutal mechanical events required to escape the lunar gravity well. The ascent stage of the lunar module, housing the astronauts, was still physically bolted to the descent stage, which was designed to serve as their launch pad. The two halves were intimately connected by a thick umbilical cord, composed of vital power cables, communication wires, and coolant lines. To separate the vehicle, the aerospace engineers relied on controlled, violent destruction. At the exact moment of ignition countdown, a terrifying sequence of pyrotechnic charges detonated simultaneously across the spacecraft. Explosive guillotines violently sliced through the entire umbilical bundle, while explosive bolts sheared the 4 physical metal connections holding the massive structure together. For one agonizing, horrifying fraction of a second, the severed ascent stage actually dropped in a terrifying freefall. It fell approximately 1 inch toward the lunar dust before the hypergolic chemicals violently mixed, and the 3,500 pounds of thrust finally caught. The explosive force of the ascending engine was absolutely devastating to the immediate landing site. As the module rapidly accelerated upward into the vacuum, the sheer violence of the rocket exhaust ripped away heavy sheets of protective gold thermal insulation from the abandoned descent stage. Furthermore, the rapidly expanding exhaust wave completely flattened the American flag they had planted just 25 feet away, a historical reality definitively proven decades later by high-resolution imagery captured from orbit by the Lunar Reconnaissance Orbiter. The triumphant splashdown of the Columbia Command Module in the warm waters of the Pacific Ocean is often remembered as the definitive end of the Apollo 11 mission. However, for the 3 astronauts bobbing in the waves, the ordeal was far from over. The space agency harbored a profound and completely unprecedented fear, a concept formerly known as planetary protection. Scientists at the time could not entirely rule out the terrifying possibility that the lunar surface harbored microscopic alien life. Consequently, the government was obsessed with the existential threat of space pathogens. Before the recovery team even allowed the crew to step out of their floating spacecraft, Navy rescue personnel tossed biological protective isolation garments directly into the life raft. The 3 men were forced to seal themselves inside these heavy restrictive suits before they were permitted to breathe the fresh ocean air. This was a strict countermeasure designed to ensure that no dormant lunar microorganisms could potentially escape and permanently contaminate the delicate biosphere of Earth. Once they were hoisted aboard the primary recovery ship, the crew was immediately transferred and locked inside the Mobile quarantine facility. This specialized, highly modified containment trailer was meticulously engineered to maintain a constant state of negative atmospheric pressure. This negative pressure system ensured that if a microscopic leak ever occurred in the metallic hull, ambient air would safely rush into the trailer rather than allowing potentially lethal alien contaminants to escape outward into the world. Inside this confined, windowed box, the astronauts spent 21 consecutive days in strict biological isolation. The air they exhaled was continuously scrubbed through a rigorous, high-efficiency particulate filtration system, and every physical sample and piece of biological waste was heavily sterilized. Medical and security agencies were deeply terrified that a strange extraterrestrial virus, against which the human immune system possessed absolute zero natural defense, could potentially spark an unstoppable global pandemic and wipe out humanity. Only after an exhaustive incubation period proved the complete absence of alien diseases were the men finally permitted to embrace their families. The voyage of Apollo 11 was never merely a triumphant victory march. It was a perilous path paved directly along the razor-thin boundary separating life from absolute death. From overwhelming digital computer errors and the corrosive, toxic lunar dust, to a single snapped plastic circuit breaker, resting in the freezing dark, fragile human beings stood at the absolute precipice. We reached out and physically touched the terrifying horizon of the unknown, armed with nothing but supreme intellectual wisdom and unyielding courage. The universe isn't broken. Our map of it is just incomplete. What do you think? Does this realization make the universe feel more terrifying or more deeply connected to us? We owe an immeasurable debt of gratitude to the heroes of the Apollo 11 mission, Neil Armstrong, Buzz Aldrin, and Michael Collins. Their unyielding courage in the face of the terrifying unknown pushed the boundaries of human achievement and paved the way for every cosmic journey that followed. Their legacy reminds us that even when standing on the razor-thin edge of disaster, human ingenuity can prevail. Thank you so much for watching. The universe is full of terrifying and beautiful mysteries, and exploring them together is what makes this journey so incredible. If you enjoyed this deep dive into the dark cosmos, please subscribe and leave a comment below. I will keep exploring. See you all next time.